Hello. Today we're looking at work problems. We're going to look at an angled one because that's the more complicated one, but the same equation applies for both. So we're looking at an older brother. Here's our older brother beating up his younger brother by dragging him along the floor at an angle of 28 degrees. So here's the floor. Here's his sibling. And then, I don't know, I'll make this a rope here. Okay? So he's getting dragged, and the angle that he's getting dragged at is 28 degrees. And the forces being exerted is 97 newtons. And then he gets dragged this way, 5.4 meters. And then he gets dragged this way by another 2.6 meters. Alright, so this question is just like any other work problem. It's looking at F net times displacement in our equation here. Here's our equation. So our F net here is what we're looking for. So the triangle looks like this. His sibling was pulling him this way at 97 newtons at an angle of 28 degrees. Okay. Now, if we are thinking about the free body diagram, there's a force of gravity here, and there is a force normal here. Force of gravity is bigger than the force of normal because you have this component of a force applied in the perpendicular direction. Okay, we've got this component, force applied in the parallel direction. Okay, so the perpendicular direction, so let's look at our F net, because that's what we need to get first. Our F net here, F net perpendicular is equal to, is he accelerating up and down? So in terms of MA, the acceleration in the perpendicular direction is 0. We want to look at our forces, Fg minus Fn minus F applied perpendicular. But we don't need to look at it anymore, because if this is 0, then we're looking for F net, so that is not going to affect our F net. So let's look at the next part, next equation here, F net parallel. So F net parallel is going to be, the only thing in this whole situation that's going parallel is actually just the F applied parallel. Okay, that's this force here. That's the only thing that is going in the parallel direction. So let's try to calculate it. Well, let's look here. SOHCAHTOA, right? SOHCAHTOA. So in this case, we're looking for the adjacent, and we have the hypotenuse. Which of these has adjacent and hypotenuse? That one. So we need to use cos. So cos, just from the SOHCAHTOA, the ka part, we're just writing cos of the angle equals adjacent over hypotenuse. That's from the SOHCAHTOA. You just have to know that. Now, if we're rearranging, we have the angle, we have the hypotenuse. So rearranging to solve for A is hypotenuse cos theta. So in this case, our hypotenuse is F applied cos theta here. Okay? So now we can take a look at we can go back. Now we have the F net. Okay, looking back at this pink highlighted part, we can sub that in for the F net. So work, I'm going to put that in green here. Work equals F net, but instead of F net we're writing force applied cos theta, okay? And we want to have displacement. So displacement is not distance. Distance would be you add these two together, but since this is dragging them, it says if you drag them then back 2.6 meters, then you subtract the two. So just like any adding of vectors in forces, 5.4 to the left, and we're calling left positive, minus 2.6 to the right, so they subtract. You're just subtracting this area from here to here. Okay, so now you plug all this stuff in, and this will be what your equation normally looks like is FD cos theta, while the D here, this D is this, and this, well, here, let's get rid of that. This F applied is F, and this cos is this. Or, if you want to think about it in a different way, FD, we can look at it like this, and we can say that F is equal to the entire thing in here, and D is still equal to the pink part. So you can think about it however you want, but this is now our equation. So our work equals, what do we have for force applied? 97 newtons times by cos of 28 times by 5.4 minus 2.6 is 2.5, 2.4 plus 4, 2.8 meters. Okay? So if we plug this into our calculator now, we have 239.8 joules, but the sig figs are 2. So your answer is going to be 2.4 times 10 to the 2 joules. And that's how you do a simple work problem.